Hello everyone, welcome to all in the series of real analysis. So अब हम स्टार्ट करेंगे functions of several variables. तो लिखिए let R be the set of real number then Rn equals to R plus R plus R n times. ठीक है, इसमें किस टाइप के एलिमेंट होंगे? x1, x2, xn, here xi belongs to R or I greater than equal to 1 smaller than equal to n. ठीक है, so let S is a subset of Rn, then f is a function from S to R which is called a real valued function of n variables. So if we take R square, then it is equals to x1, x2, here x1 and x2 belongs to R, and the function from R square to S, which is subset of R square to R, is called a function of two variables, a real valued function of two variables. And here S is the domain of this function, and range of the function is a subset of R. ठीक है, अब लिखिए neighborhood of a point. Let AP belongs to R square be a point, then the set where x is greater than a minus h and smaller than a plus h, and y is greater than p minus k and smaller than p plus k, is called a rectangular neighborhood of the point AB. It's called a rectangular neighborhood of point AB. Where h and k are arbitrary small positive real number. and the neighborhood of a point AB is denoted by NBD of AB. ठीक है. And if we delete the point AB from the neighborhood, of the point AB, then the remaining set is called the deleted neighborhood of AB. Now the set equals to such that x belongs to R and y belongs to R, and under root x minus a whole square plus y minus b whole square is smaller than डेल्टा. ठीक है, इसको हम क्या बोलेंगे, इज कॉल्ड अ सर्कुलर नेबरहुड ऑफ पॉइंट ए बी. ठीक है, where delta is very small positive number, arbitrary small positive number. Now एक नोट लिखिए कि every rectangular neighborhood of a point is circular neighborhood and vice versa. Every rectangular neighborhood of a point is a circular neighborhood and vice versa. ठीक है, नेक्स्ट लिखिए लिमिट पॉइंट. A point AB is called a limit point of a set S if every neighborhood of AB contains an infinite number of points of S. लिमिट पॉइंट को हम कंडेंसेशन पॉइंट भी बोलते हैं. एक एग्जांपल देख लेते हैं. एक सेट है हमारे पास 1/m 1/n, here mn belongs to R. Then 0 0 is limit point of the set S. Next लिखिए limit of a function of two variables. Let S is a subset of R. R2 and f is a function from S to R. Then f is said to have limit L as a point AB tends to if a point xy tends to AB, if for every small arbitrary positive number epsilon there exists a delta greater than 0 such that fxy minus L is smaller than epsilon whenever x minus a is smaller than delta and y minus b is smaller than delta, and it is denoted by फाइन. अब एक क्वेश्चन देख लेते हैं. Prove that limit of the function xy x square minus y square upon x square plus y square when xy tends to 0 0 is equals to 0. So let's solve. We are given that fxy is equals to xy x square minus y square upon x square plus y square. Now using x equals to r cos theta and y equals to r sin theta, we get fxy minus 0 is equals to fxy is equals to xy x square minus y square upon x square plus y square. And after putting x equal to r cos theta and y equals to r sin theta, we get r square sin theta cos theta cos 2 theta. And it is equals to r square sin 4 theta by 4. और इसको हम कैसे लिख लेंगे? sin theta cos theta equals to sin 2 theta by 2. ठीक है. And then sin 2 theta cos 2 theta equals to sin 4 theta by 2. तो इसलिए क्या आ गया? sin 4 theta by 4. And value of sin x is always smaller than equal to 1. So यहाँ पर हम क्या लिख देंगे? It is smaller than equal to r square by 4. ये r square by 4 हमेशा पॉजिटिव होगा, so इसको हम लिख देंगे r square by 4. मॉड्यूलस को हटा देंगे. फाइन. और क्या आ गया? एफ एक्स वाई माइनस 0 इज स्मॉलर देन इक्वल टू आर स्क्वायर बाई 4. एंड आर स्क्वायर क्या हो जाएगा? एक्स स्क्वायर प्लस वाई स्क्वायर बाई 4. देखिए एक्स क्या था? आर कॉस थीटा. वाई क्या था? आर साइन थीटा. So x square equals to r square cos square theta and y square equals to r square sin square theta. Then x square plus y square equals to r square cos square theta plus sin square theta. And cos square theta plus sin square theta equals to 1. So x square plus y square equals to r square. And it is smaller than epsilon if x square by 4 is smaller than epsilon by 2 and y square by 4 is smaller than epsilon by 2. या फिर हम कहते हैं और मॉडुलस ऑफ x is smaller than under root 2 epsilon, जिसको हम डेल्टा ले लेते हैं, and modulus of y is smaller than under root 2 epsilon. ठीक है. Thus, for any given epsilon greater than 0, there exists delta equals to under root 2 epsilon, which is greater than 0, such that x square plus y square, और सॉरी ऊपर माइनस आएगा, x square minus y square upon x square plus y square minus 0 is smaller than epsilon whenever modulus of x is smaller than under root 2 epsilon, यानी डेल्टा, and modulus of y is smaller than delta. Therefore, limit of the function when xy tends to 0, 0 is equals to 0. Fine. Next देखिए non-existence of limit. So if we can find two functions such that the limit of f x phi 1x and f x phi 2x are different, then the limit of fx phi does not exist. एक एग्जाम्पल देख लेते हैं, उससे ज़्यादा अच्छे से समझ आएगा ये. Show that the limit does not exist. So suppose that the point xy approaches to 0, 0, along y equals to x, along the line. Then limit x tends to 0, f x x is equals to limit x tends to 0, x x cube upon x square plus x की पावर 6 is equals to limit x tends to 0, x square upon 1 plus x raised to the power 4. ठीक है, and it is equals to 0 because x tends to 0. Then again let xy approaches to 0, 0 along the cube, along the curve y cube equals to x. Then limit x tends to 0, fx is equals to limit x tends to 0, x upon x square plus x square, which is equals to limit x tends to 0, x square upon 2x square. x square से x square cancel out हो जाएगा, तो इसकी लिमिट क्या आ जाएगी 1/2. Since along two paths we get different limit, so therefore limit of the function when xy tends to 0, 0 does not exist. So therefore limit does not exist. Fine. अब लिखिए continuity of a function at a point AB. Let S is a subset of R square and F is a function from S to R. Defined in some neighborhood AB, then F is said to be continuous at point AB. If for any given epsilon greater than 0, there exists delta greater than 0 such that fxy minus fab is smaller than epsilon whenever modulus of x minus a is smaller than delta, modulus of y minus b is smaller than delta. And in other words, f is said to be continuous at point AB if limit of the function fxy when xy tends to AB is equals to fab. Now we will solve a question. Test the continuity at 1, 2. Of the function fxy is equals to x square plus 4y when xy is not equals to 1, 2 and 0 when xy is equals to 1, 2. So limit xy tends to 1, 2 x square plus 4y fxy is equals to limit xy tends to 1, 2 x square plus 4y is equals to 1 plus 4 into 2. That means 9. So now limit xy tends to 1, 2 is equals to 9 and it is not equals to 0. Value of the function at 1, 2. Okay. So therefore the function is not continuous at 1, 2. एक और क्वेश्चन सॉल्व करते हैं. There is a function from r square to r defined by y square minus x square xy divided by x square plus y square. For xy not equals to 0, 0 and is equals to 0 when xy is equals to 0, 0. ठीक है, हमें शो करना है कि जो फंक्शन है ये कॉन्टिन्यूस है एट पॉइंट 0, 0, एट पॉइंट 0, 0 पर ये कॉन्टिन्यूस प्रूफ करना है. So let us first show that limit of fxy at point 0, 0 is 0. ठीक है, so let epsilon is greater than 0 and for all xy not equals to 0, 0 we have fxy minus 0 is equals to y square minus x square plus y square is equals to y square minus x square and xy upon x square plus y square by using the property of modulus, that modulus of AB is equals to modulus of A modulus of B. Fine. So now for all x and y we have modulus of x minus modulus of y whole square is greater than equal to 0. This implies that modulus of x plus modulus of y whole square minus 2 modulus of x modulus of y is greater than equal to 0. This implies that x square plus y square is greater than equal to 2 modulus of x modulus of y, and इसको हम क्या लिखते हैं 2 modulus of xy. ठीक है, so this implies that xy upon x square plus y square is smaller than equal to 1 by 2 if xy is not equals to 0, 0. ठीक है, अब जो ये हमारे पास ये वाली इक्वेशन थी इसको हम मान लेते हैं 1 एंड इसको हम बोल देते हैं 2. So using first and 2 we get for all xy not equals to 0, 0 fxy minus 0 is smaller than equal to 1 by 2 y square minus x square is smaller than equal to 1 by 2 y square plus x square is equals to 1 by 2 x square plus y square, which is smaller than epsilon when x square is smaller than epsilon and y square is smaller than epsilon. That is, modulus of x is smaller than epsilon and modulus of y is smaller than, under root epsilon is smaller than under root epsilon. And if we take under root epsilon is equals to delta, then we observe that for any epsilon greater than 0, there exists delta greater than 0 such that modulus of fxy minus 0 is smaller than epsilon whenever modulus of x is smaller than delta and modulus of y is smaller than delta. Now, since limit of fxy at xy tends to 0, 0 is equals to 0, and it is given that value of fxy at 0, 0 is equals to 0. This implies that f00 is equals to limit xy tends to 0, fxy is equals to 0. That is, function fxy is continuous at 0. That means at origin. लिखिए डायरेक्शनल डेरिवेटिव. Let S is subset of R square and F is a function from S to R. And C belongs to S. And let U equals to U1, U2 belongs to R square. Then the directional derivative of F at C of function F at point C in the direction of U is defined as limit of fc plus hu minus fc by h, and h tends to 0, provided this limit exists and denoted by f dash c. So जब ये लिमिट एग्जिस्ट करेगी तो इसको हम बोलेंगे डायरेक्शनल डेरिवेटिव ऑफ f एट पॉइंट c इन द डायरेक्शन ऑफ u. एक क्वेश्चन सॉल्व कर लेते हैं. Let fxy equals to xy square upon x square plus y raised to the power 4 when xy is not equals to 0 and 0 when xy equals to 0. Then find the directional derivative along u. Where u equals to under root 2 at point 0, 0. So fxy equals to xy square upon x square plus y raised to the power 4. So f dash cu equals to limit h tends to 0 fc plus hu minus fc upon h, and it is equals to limit h tends to 0 f of where c is 0 and h is h and u is under root 2 and under root 2. Minus f of c, f of 0 upon h. So it is equals to limit h tends to 0 f of 0 plus under root 2h and 0 plus under root 2h. माइनस एफ ऑफ 0 इज इक्वल्स टू 0, सो यहाँ 0 लिख देंगे अपॉन एच. So it is equals to limit h tends to 0 f of under root 2h under root 2h divided by h, and it will be equals to under root 2h under root 2h whole square upon under root 2h whole square plus under root 2h whole की power 4 divided by h, and it is equals to under root 2h square upon h 2h square plus 4h raised to the power 4. Then h से h cancel out हो जाएगा and under root 2 limit h tends to 0. Limit h tends to 0 under root 2 2h square को कॉमन ले लेंगे, then 1 plus 2h square, फाइन 2h square से 2h square को कैंसिल आउट कर देंगे एंड देन क्या बचेगा, लिमिट h tends to 0 under root 2 upon 1 plus 2h square, and after applying limit it will be equals to under root 2. So under root 2 क्या आ गया, directional derivative along u which is equals to under root 2 at 0 0. नेक्स्ट डेफिनेशन लिखिए, पार्शियल डेरिवेटिव्स. So let s belongs to r square and f is a function from s to r of two independent variables x and y defined at point AB belongs to S. Then the partial derivative of f with respect to x is the ordinary derivative of f with respect to x and y with respect to x when y is treated as constant and denoted by fx or del f by del x. In other words, if limit h tends to 0, f of a plus h p minus f a b upon h exists, then the limit is called partial derivative of fxy with respect to x at point AB. at point AB. ठीक है, and is denoted as del f by del x at AB or fx at AB. Fine. Then the partial derivative of f with respect to y is the ordinary derivative of f with respect to y when x is treated as constant. And it is denoted by fy or del f by del y. Fine. एंड हम ऐसे भी बोल सकते हैं कि लिमिट k टेंड्स टू 0 f a b प्लस k माइनस f a b upon k exists if the limit of this exists, then it is called the partial derivative of fxy with respect to y at point AB, and it is denoted by del f by del y at point AB or fy at point AB. फाइन. एक क्वेश्चन सॉल्व कर लेते हैं. The question is, using definition, calculate fx and fy at 0, 0 if f is a function from r square to r defined by fxy is equals to xy square by x square plus y raised to the power 4 for xy not equals to 0, 0 and f0, 0 is equals to 0. So let's solve it. Fx at 0, 0 is equals to limit h tends to 0 f0 0 plus h 0 minus f0, 0 by h, and it is equals to limit h tends to 0 f h0 minus f0, 0 by h, and it is equals to limit h tends to 0 f h0 is also 0 and f0, 0 is also 0 by h, so it is equals to 0. Now the partial derivative of f with respect to y at point 0, 0 is equals to limit k tends to 0 f of 0, 0 plus k minus f of 0, 0 by k, and it is equals to limit h tends to 0 f of 0 k minus 0 by k, and is equals to limit k tends to 0 f0k is 0, then 0 minus 0 by k, and it is equals to 0. ठीक है, so partial derivative of f with respect to x is 0 and partial derivative of f with respect to y at point 0, 0 is also 0. So आज के लेक्चर में हम इतना ही करेंगे. अब नेक्स्ट लेक्चर में हम कुछ और पढ़ेंगे. मैट्रिक्स ऑफ डेरिवेटिव, differentiability, partial derivative of higher order and extreme values. So thank you.